Let's jump right into this explainer. Today, we're popping the hood on the invisible engine that powers the creation of absolutely everything in our modern physical world. Whether you realize it or not, almost every single manufactured object you interact with today began its life inside a very specific, highly controlled digital environment. Think about it for a second. How does that spark of an idea in your head actually turn into the office building you work in, or the car sitting in your driveway? You can't just hand a builder a sketch on a napkin and expect a skyscraper. You need total precision. You need exact measurements. And you need a universal language that engineers, architects, and builders can all understand at the exact same time. Bridging that massive gap from human imagination to physical execution is exactly what we're decoding today. All right, let's look at Section 1, the drafting revolution. This is all about the transition from clunky manual drawing boards to a digital design environment. So, computer-aided design and drafting, or CAD for short, is basically our ultimate digital toolkit. It takes engineering out of physical constraints and drops it into a mathematically perfect software ecosystem. This means we can build and stress test insanely complex designs long before a single piece of material is ever cut or poured. And this historical shift from manual to digital drafting, it was absolutely massive. We're not just talking about throwing away pencils and erasers here. It eliminated the huge bottleneck of human error. CAD replaced these fragile, completely uneditable paper systems with a hyper-accurate digital world. Now, you can push a cascading revision through the entire project in seconds instead of weeks. Honestly, it completely rewired how projects operate from the ground up. By driving unparalleled accuracy and letting multiple engineers collaborate globally on standardized files, CAD totally broke down traditional silos. It literally turned flat, static blueprints into dynamic, intelligent models. Moving right along to Section 2, inside the CAD toolbox. Let's actually crack this thing open and look at the software. The wild thing about this ecosystem is how beautifully it scales. You start out basic with 2D drafting for flat layouts and step up to realistic 3D modeling. But the real magic happens at parametric design, where changing one mathematical variable instantly updates the physical elements across the board. And all of this culminates in BIM, or Building Information Modeling, where every single digital brick or beam actually holds live, real-world data. Now, how does this look in the wild? While AutoCAD is still the absolute standard for foundational 2D and 3D drafting, architects, on the other hand, practically live in Revit to manage that data-rich BIM environment we just talked about. If you're doing intense, granular mechanical details, you're firing up SolidWorks. And for those wildly complex aerospace or manufacturing jobs, specialized platforms like CATIA or Fusion 360 are your go-to. But look, it's not all perfectly smooth sailing. Implementing enterprise-level CAD takes a massive financial investment. And we aren't just talking about software licenses. You need absolute powerhouse hardware to render these massive BIM models. Toss in a seriously grueling learning curve, and yeah, the operational barrier to entry is pretty steep. Let's pivot to Section 3, Building the Real World. This is where we see how these tools actually shape our physical environment. In civil and architectural engineering, CAD is quite literally the backbone of our infrastructure. It dictates everything from complex interior floor plans to the precise mathematical mapping of entire city drainage systems. It's the reason our large-scale urban planning is structurally sound and functionally resilient. And then, if you zoom way in, mechanical and electrical applications are just as vital. Mechanical CAD is the exact reason the gears in your car fit together down to the millimeter. Electrically, it drafts the intricate circuit layouts that keep our sprawling power grids humming and the tiny microchips in your phone functioning flawlessly. Which brings us to Section 4, Careers and Future Trends. Where exactly does all this design power go next? Since CAD is basically the central nervous system for construction, manufacturing, and engineering, having these skills gives you immense industry leverage. If you pair strict drafting standards with high software proficiency, you're looking at highly specialized roles, whether that's a BIM engineer optimizing the footprint of a new skyscraper or a design engineer modeling next-generation tech. So, if these digital tools are already this universally powerful and deeply embedded in how we make things, you have to wonder, what does the next generation of drafting actually look like? Honestly, the future here kind of borders on sci-fi. We're looking at massive AI integration where the software autonomously optimizes structural integrity before an engineer even asks. Then there's the explosion of digital twins. These are exact live data replicas of physical buildings and running machines. Add in global cloud collaboration and VR capabilities, And soon, you'll literally be walking through your engineered designs in virtual reality before a single physical component is ever manufactured. It's a total game changer. So, the big takeaway from all this source material in today's explainer, CAD is not a luxury, and it hasn't been optional for decades. It is the absolute, non-negotiable bedrock of modern engineering, architecture, and manufacturing. It's the definitive language that translates our human innovations right into physical reality. I want to leave you with a thought to spark your curiosity. If you had the ultimate digital toolbox at your fingertips, if you could harness this invisible engine of modern creation, what impossible idea would you design and build tomorrow? Definitely explore the incredible world of CAD on your own. It's pretty amazing what you might create.